So, ang lesson natin is all about friction in this session. And to start with, define muna natin ang ibig sabihin ng friction. Friction is actually a contact resistance exerted by one body upon a second body when the second body tends to move past the first body. I repeat, friction is a contact resistance exerted by one body upon a second body when the second body tends to move past the first body. So that's the definition of friction. And as a continuation, the frictional resistance is assumed to be proportional to the normal pressure, and it is expressed as F equal or directly proportional to normal force or normal pressure. F, then alpha N, yan ang symbol natin, which is simplified by using a constant proportionality equal to mu. Yan ang symbol na ginagamit natin ng mu, which depends on the roughness of the contact surfaces. This constant is called as the coefficient of friction and is written as, ito yung symbol na ginagamit natin. So, frictional force is equals to mu times N or the normal force. So, initially, yan muna ang definition ng ating friction. And then, ibinigay ko yung dalawang formula na nakasaad sa ating slide. From the figure shown below, a body having a weight W will have a normal force equal to N. The frictional resisting force is equal to F mu times N. So, tingnan niyo yung block of wood natin naka-incline with an angle of inclination of theta. Now, in order to calculate for the frictional force or frictional resisting force, that is simply equal to mu times N. Yan kasi yung nag-oppose yung frictional force doon sa direction ng applied force natin na P sa figure natin. Ngayon naman, ito naman is hindi siya nakaslant. So, same pa rin ang formula natin. F is equals to mu N. So, take note of these two figures. Makakapag-form tayo ng mga equations. Una sa lahat, weight is equals to normal force. Parang yung kanina, yung Newton's third law of motion. Actually, Newton's third law of motion. Action force and reaction force. Ang action force natin is yung weight. And then yung normal force, ito yung ating reaction force. Laging equal lang yung dalawa. Okay? So another equation that we can form, force is equal to mu n, the frictional force, the force that contradicts the direction of the applied force, mu times n, or coefficient of friction times the normal force, para mahanap natin ang value ng ating frictional force. And then, for the second figure, normal force is actually equal to weight times cosine theta. Application na yan ng trigonometry, no? Sa ating friction. Dahil naka-incline nga yung block of wood natin at a certain angle. And then, introducing another formula, same pa rin. Hindi magbabago ang formula ng ating frictional force. Frictional force equals to mu times the normal force. Ang nagbago lang yung value ng normal force natin kasi nga naka-incline yung block of wood natin. So, kailangan natin lang tulong ng trigonometry. And then, frictional force is also equals to mu times W cosine theta. Since ang value ng normal force is equals to W cosine theta, so nag-substitute lamang ako dito. Ito siya. Since ang value ng N is equal to this, so yung N natin dito, pinalitan ko ng W cosine theta. So, ganyan na-derive yung formula ng frictional force nating formula na bago. So let's proceed. Question? Wala ba kayong tanong sa formula? Wala ba kayong tanong sa formula, mga anak? Gagamitin natin yan mamaya sa ating mga problem solving. Wala ba kayong question? Sa mga diagrams natin, sa mga figures natin. James, question so far?
Wala pa naman po.
Okay, so let's proceed. Another figure. So let's talk about the angle of static friction. So let me introduce the formulas. Tangent theta sub s equals to force over normal force. Yung S, ibig sabihin nasa static friction tayo, no? Yung subscript na S ng theta natin. And F is also equals to N tangent theta sub S. F is equals to coefficient of static friction times the normal force. Tandaan niyo yung mga formula na yan. Kakailanganin natin ang mga yan. And tangent theta S is equal to mu S. Wherein theta sub S equals to the angle of static friction. Mu S is the coefficient of static friction. Where theta S is reached at impending sliding. May letter I yan, no? Impending pa lang yung sliding natin. Okay, that is all about the angle of static friction. Now about when sliding occurs, tangent theta k is equals to mu k. So angle of kinetic friction tayo. So coefficient of kinetic friction naman ang mu k. F is equals to mu k times the normal force. Mu k is actually equal to the coefficient of kinetic friction. And theta k, pinalitan ko ng konti yung symbol ng theta, no? Naging nakaslant yung cross niya para hindi malito. So angle of kinetic friction yan. Now let us define again frictional force. What do we mean when we say frictional force? It is the force acting on the body whenever it moves while in contact with another body. This force always opposes the direction of the motion. The frictional force is proportional to the normal force and is directed parallel to the surface. So that's how we define frictional force. At yan ang formula again ng ating frictional force. Question so far? Malinaw ba ang mga formula na gagamitin ninyo? Alam na ninyo ngayon yung mga formula na kakailanganin ninyo mamaya. So na-introduce ko na sila. Mu, again, ang ibig sabihin, coefficient of friction. Now, coefficient of kinetic friction, ito yung definition natin. The ratio of frictional force to the perpendicular force pressing the two surfaces together. And this is our formula for coefficient of kinetic friction. Equal to force over normal force. Frictional force over normal pressure or normal force. How about the coefficient of static friction? The ratio of the limiting frictional force to the normal force. And for the formula, same lang. Frictional force over normal force. Nagbago lang yung symbol ng ating coefficient of friction. Nasa static lang siya. Okay, let me raise a question to each and every one of you. Sa palagay ninyo, bakit importante ang friction sa engineering? Pwede ba kayong mag-brainstorm or mag-isip kung bakit, kung ano yung dahilan, kung bakit napaka-importante ng friction sa engineering? Volunteer. I want to hear some words or messages from you regarding about this question. Why is friction important in engineering? Tatawag ako. Bakit importante ang friction sa engineering? Imagine niyo yung course niyo, bakit kaya pinag-aaralan natin ang friction? Bakit ang hihirap ng mga problem na kinocompute natin kapag tinatakal natin ang friction? Ano nga ba? Bakit importante yan sa engineering? Di naman siguro natin pag-aaralan yan kung di importante sa engineering. Any idea or opinion?
Ano po siguro sir, yung pong dun pag po kasi alam natin yung friction, alam po natin din piliin yung mga materials na gagamitin natin. When it comes sa road po, since present po lang yung friction doon, so technically po kailangan piliin natin yung mga high tensile sa friction po para maiwasan na din po yung harm na pwedeng dala po ng mga bagay na po kapag yung friction po is hindi kaya ng material.
Very
Ganyan.
good. So that's one point. Tama ka, James, doon anak, no? Yung mga materyales, iba-iba yung roughness ng mga yan eh. Diba? So pinipili natin yung mga materyales na may magagandang properties na fit doon sa roadway na ating i-construct. Sa transportation engineering yan anak, napaka-importante na binibigyan natin ng importansya ang friction or consideration while we are designing roadways. Nang sa gayon maging safe yung mga tao, yung mga gagamit ng roadways sa pagkakakonstruct nito. So binibigyan natin ng importance ang friction. Now generally, importante ang friction sa engineering. Bakit? Ito yung reason. Ito yung importance niya. Engineers need to, okay, pakibasa nga, Maglaya.
Engineers need to understand the force of friction so that they can design safe roads, tires, cars, and brakes. Engineers also try to reduce the force of friction between moving mechanical parts so that they will last longer.
That's it. So, engineers need to understand the first